So hello students, moving ahead in our series. Today we are going to solve our next question. So I estimate this question to be a question in the like level of 3 marks question. The question is if p of x is a polynomial of degree n. So we are given that p of x is a polynomial of degree n where we are given p of xi is equal to 1 by xi for all I going from 1 to 3 till n plus 1 बच्चों. Now what is this information all about? What does this information tell us? This information tells us that let us assume an equation p of x is equal to 1 by x. So if I assume this equation, so this equation is being satisfied by x is equal to 1, 2, 3 till n plus 1. Now when an equation is being satisfied by some number or some value of x, what are those values of x called? They are called the solution or the roots of the equation, isn't that? So what do we know? So this implies that this equation, which if I cross multiply gives us x times p of x is equal to 1, has how many roots? Roots as, so the roots are n plus 1 roots, has roots x is equal to 1, 2, 3, and it's a polynomial equation. Now from your childhood you all know that if we know the roots of a polynomial, we can write it in factor form. So what I can write? So I can write x times p of x minus 1 is equal to, so factors should be x minus 1 into x minus 2 into x minus 3. Since they are all roots, they form a factor. So we can easily write the polynomial equation in the form of its factor. But we need to keep in our mind that, see, p of x is a nth degree polynomial, is a polynomial of degree n. So of course x into p of x will give us a polynomial of degree n plus 1. So it's quite obvious that it has n plus 1 roots. Okay, but then do we know the leading coefficient? Leading coefficient, what is leading coefficient? Leading coefficient is the coefficient of highest degree term. We don't know anything about the leading coefficient. So I put unknown constant a to take care of the leading coefficient because we can't be sure that it's 1 or any other number. Okay. Now see, the entire focus should be to find a. So to find a, what will I suggest? I will suggest put x is equal to 0. Okay, because we don't know the value of polynomial p of x at any for any value of x or at any point x. So put x is equal to 0. So what do you get? 0 into p of 0 minus 1 is equal to a times. So minus 1, yeah, just a minute. So a times minus 1 into minus 2 minus 3 and so on minus n plus 1. So what is it? So of course in LHS it's minus 1, in RHS it's a times, how many minus negative we have? In RHS we have n plus 1 times minus 1 into n plus 1 factorial. So what is a here bachcho? A is minus 1 raised to the power n over n plus 1 factorial. Hence we got our polynomial x into p of x. So therefore x into p of x minus 1 is minus 1 raised to the power n over n plus 1 factorial whole into, so whole multiplied by whole into x minus 1 into x minus 2 and so on till you reach the last factor x minus n plus 1 bachcho. Okay, now see, we have to get the value. So we are given for n is equal to 2017, get the value of polynomial at x is equal to 2019. So what does that mean? That means here we will replace n by wherever we have n by 2017 and we will replace x wherever we have it by 2019. So just do it. So if we do it, what do we get here? So in LHS, what do we get? 2019. We are replacing x by 2019 into p of 2019. That's what actually we need. Minus 1 is equal to minus 1 raised to the power n, which is 2017 over n plus 1 2018 factorial, and then it's x is 2019. So 2019 minus 1 into 2019 minus 2 and so on 2019 minus 2018 and plus 1 is 2018. What do we get in RHS? See, this is 2018, 2017 and this is equal to 1. So in RHS we have product from 1 to 2018, which is nothing but 2018 factorial, and since we have odd power over it, so it's negative 1. So 2018 factorial, and here also we have 2018 factorial multiply, and we got it. So what do we have? So finally what are we left with? 2019 times P of 2019, whose value we need, minus 1 is equal to minus. Interestingly, they get 0. And since, of course, 2019 can't be 0, too obvious, so P of 2019 has to be 0. So that was a simple question. If we understand that we can use this information to write a polynomial equation in this form, where we know that it has n plus 1 roots, and using the basic remainder theorem, we can write the polynomial equation in terms of the factors. Okay, and that holds the key, bachon. Okay, so that's it for today, and we'll continue with such questions in our upcoming videos, bachon. So stay tuned, and with all the best wishes for the upcoming exam, let's stay connected. Bye, bachon.